All right, we're going to look at these last few dividing of exponents examples. This is going to use a mix of all of the properties that we've learned so far, including the multiplication properties, the division properties, and the zero exponent and negative exponent properties. So here we have w to the power of 5 times m to the power of 3 over w to the power of 9. The w's are the same base, so we are going to subtract their exponents since they are being divided. So this turns into w to the power of 5 minus 9, and then m to the power of 3 was still on top. When we simplify this, 5 minus 9 gives us a negative 4. So we have w to the negative 4 and m to the power of 3. Well, w to the negative 4, that negative exponent, is going to force it to move downstairs. The m to the power of 3 is not negative, so that can stay on top. That's going to stay upstairs. So m to the power of 3 over w to the power of 4 is our final answer for example 3a. Looking over example 3b, we have two k bases that are the same. They have different exponents, one with a negative 2, one with a 5. And then we have m to the power of 4 on the bottom. That m to the power of 4 is going to stay on the bottom. It's not negative, it doesn't have a negative exponent, it's not going to move. So I'm going to take k to the negative 2 minus 5 over m to the power of 4. And then I'm going to simplify these exponents. I have negative 2 minus 5. So k to the negative of 7 over m to the power of 4. Now that k has a negative 7 exponent, so that means it's going to move downstairs with the m. So our final answer is 1 over k to the power of 7, m to the power of 4. These last two might be a little bit more complicated. We have a base of 3 on the top and bottom, and then we have m to the power of negative 3. So first I'm going to deal with the 3's. We have the quotient of powers being used here, so one is on the top, one is on the bottom, so we are going to subtract their exponents. So we have 3 to the power of 5 minus 9, and then m to the power of negative 3. I am going to deal with that negative 3 for the power of m, but I'm going to go ahead and simplify for the 3 first. 5 minus 9 gives us a negative 4, and then m to the negative 3. Now both of my exponents are negative, so that means they both are going to go downstairs, which is why I waited. So we have 1 over 3 to the power of 4. Again, once those exponents move downstairs, they are no longer negative. And then m to the power of 3. So this is an acceptable answer. You could also go ahead and simplify the 3 to the power of 4. You can use a calculator doing that. Remember, if there's no letters, you can always type the number and the exponent into the calculator to get the final answer. 3 to the power of 4 is 81. And then m to the power of 3. So either of these work as a final answer for me. Now lastly, we have example 4b, and if I look at example 4b, I have a k, an h, and an m, so none of those bases are the same, but I do have this negative 10 and a 2. Now those are both big numbers, they're both bases. So we're going to treat that like a regular division problem. There is not a negative exponent here for the 10. That is a negative 10, not an exponent of negative 10. So if we think about negative 10 over 2, what that turns into is negative 5, or negative 5 over 1. So if we add that to the rest of our problem, we have negative 5, k to the negative 2, over h to the power of negative 5, m to the power of 4. Now I have two negative exponents. I have k to the negative 2 That's on top, so it's going to move down to the bottom. And then we have h to the negative 5 on the bottom. If something is negative on the bottom, it's going to move up to the top. So when we do this switching around, we end up with negative 5 on top, h to the power of 5. And then on the bottom, we have k to the power of 2 and m to the power of 4. So again, once they change locations, the negative for the exponent goes away. Now you could technically switch k and m in their position as in terms of left and right on the bottom. We try to keep it in alphabetical order just so it's organized. So please try to do the same.